Hey guys, today we're going to look at factorial design for three independent factors. So we have our data over here to the left, and it's just how long it took students to walk to campus with these different factors. So it's a factorial 4 by 4 by 5 design with the factors being street, time of day, and day of week. It's a completely randomized design with 4 repetitions of each combination. The experimental units are going to be the students walking, and the response time is is just me the time taken to walk to campus. So here you can see a little example of how the random assignment may have gone. So each circle is going to represent an experimental unit, so a student, and this is the first treatment combination, and you can see that it has 4 different randomly assigned students, and this would be similar for all 79 of these all other 79 of these treatment combinations, just randomly assigned to these 4 students. So we're going to go into the effects model, and I'm just going to kind of go through and explain what each of these would mean in the context of the study. So here we're going to have our mu, which is our overall mean for the time taken to go to campus. So that's going to be our mu. And then our alpha I, beta j, and CZ are going to be our factor effects. So this is our alpha I is going to be the effect of the ith response of the ith effect of the street on the response, and then the jth effect of the time of day on the response, and then the zth effect of the day of the week on the response for the alpha, beta, and C respectively. And then next we're going to look at the interaction terms. So the interactions are going to be for each factor, between each factor. So the alpha and beta ij is going to be the interaction term for the cross between street and time of day. And that's similar for B and C, where it's going to be time of day and day of week. And then alpha and C is going to be street and day of week. And then lastly is going to be the interaction term for the effect of the all 3 of these variables crossed together. And then we have our error term, which is just the error for the ith response, the ith street, the jth time of day, the zth day of week, and the kth repetition. And again, we just assume that these errors are about normal. So I kind of already went over this a little bit, but just to see it again, our alpha is going to be our street. So our first factor, our second factor is time of day, and our third factor is day of week. There are values that each is going to take on. The I is going to be 1 through 4 for each street. The J is going to be 1 through 4 for each time of day. The Z is going to be 1 through 5 for each day of week. And the K is going to be 1 through 4 for each repetition. Here we just have a quick look at the ANOVA table of the first 2 columns and what it should look like. So these first 3 factors, it's just simply the number of levels minus 1 in the factor. So the street degrees of freedom is just going to be 3, since we have 4 levels, so it's 3. That's similar for those 3 factors. The interaction terms are just what are going to be what you found up here multiplied together. So for the interaction term for street and time of day, you're just going to have 3 times 3, and we have 9. That's similar for all of these, along with the interaction for all 3, which is going to be all 3 of those values up here multiplied together. And then our errors. One thing to notice about here is you have ABC times n minus 1. So one thing to note is that if you don't have multiple repetitions for each treatment combination, your n is going to be 1. So it's going to be, and n is the number of repetitions. So in our case, it's 4. So we have 3 here, but if it was 1, you would get 0 for the error, and therefore you wouldn't be able to continue on with your ANOVA analysis. So in that case, we would just take out this term right here, the 3-way interaction term. And then our total is just the responses minus 1. So lastly, we're going to look at the assumptions. So our assumptions are that first, our errors are independent, and we can assume that from the design of the study, and we have a completely randomized design, so we should be okay there. Our second assumption is going to be the errors are normal, and you can see that these points here follow the line pretty closely. So there shouldn't be any problem with normality, and as we can see by this p-value, it's really large, so there's no reason to believe that our assumptions were violated for normality. And lastly, we're going to check our equal variance assumption, and you can see the predicted residuals by predicted plot. There's no clear fanning either way, so our equal variance assumption should be all right as well. Thanks for watching.